Welcome to the Stone Den. If you look closely near the mouth of the crevice, you'll spot our guide, the wise Math Shiba, keeping a quiet watch over the rocks. Deep inside the rockfall is Mossback. He's a wood rat with a bit of an architectural problem. He needs to figure out exactly how much space, the total volume, is inside his newly excavated den chambers. To measure the volume of any solid space, you have to find out exactly how many identical unit cubes it takes to pack that space perfectly, from corner to corner, leaving zero gaps and having zero overlaps. You could try dropping blocks in randomly, but the easiest, most reliable way to measure is to organize them. First, build out a single flat layer on the floor, count those cubes, and then figure out how many identical layers stack up to the ceiling. Once the space is filled, the physical edge length of the specific cube you chose gives your volume measurement its final name. Let's look at Mossback's first chamber. He decides to measure this space using small, hand-carved stone cubes, where every edge is exactly 1 centimeter long. Watch him work. He gently nudges the blocks together, perfectly aligning them on the floor of the den to build out a solid base layer. Now we can count that first layer. He lines up 3 cubes across the front, and rows that go 4 cubes deep. 3 rows of 4 gives us exactly 12 cubes on the floor. At this point, he could just keep dropping in blocks and counting them one by one until he reaches the roof, but it's incredibly easy to lose track or miscount that way. Instead, he takes another 12 cubes and stacks a second, perfectly identical layer right on top of the first one. Since the chamber is now full to the ceiling, finding the total is a simple addition problem. The 12 cubes on the bottom layer plus the 12 cubes on the top layer. 12 plus 12 is 24. And because the edge of each stone block is exactly 1 centimeter, the final volume of this chamber is 24 cubic centimeters. By organizing physical space into flat, uniform layers, you skip the tedious counting and turn the entire process into a quick, reliable calculation. Now, consider what would happen if Mossback decided to measure the exact same space, but used larger blocks, where every edge was exactly 1 inch long instead of 1 centimeter. Look at these 2 blocks side by side. A block with a 1 centimeter edge measures volume in cubic centimeters. A block with a 1 inch edge measures volume in cubic inches. If he used massive blocks with a 1 foot edge, the unit would be cubic feet. Because the 1 inch block is physically larger, it takes far fewer of them to fill up the exact same den space. A volume number means nothing on its own. The measurement only makes sense once you clearly define the specific block you use to fill the space. Sometimes you don't have standard rulers or precisely milled blocks. You just have the materials around you. Here, Mossback finds a pile of naturally uniform, square pebble cubes. He carries them into a new chamber, packing them tightly to eliminate all gaps. He counts out exactly 8 of these pebble cubes before the space is entirely full. Even though it isn't an official metric or imperial unit, the math still works. The volume of this space is simply 8 pebble cubes. Any physical object can be your unit of measure, as long as it's an identical, perfectly space-filling cube. Surveying the den, we see his completed work. 3 separate, fully packed chambers holding their respective measurements. 1 packed with 24 cubic centimeters, 1 holding cubic inches, and a smaller nook packed with exactly 8 pebble cubes. The method is always the same. Count the perfectly packed cubes layer by layer, and let the edge of the chosen cube dictate the official name of your unit. With the hard work done and the chambers packed completely flat, Mossback finally settles into his comfortable home. Up at the crevice, the wise Math Shiba gives a final nod. "Count the cubes," he says. "Name the unit by the cube. I'll see you at the next bend." Capturing the exact size of a 3D space is straightforward once you know how to pack it. True mathematical precision just requires a methodical count and the exact vocabulary to name what you have built.